Solving equations. Of course, these equations are going to be dealing with exponential functions and logarithmic functions. So let's start off with the easy type. The easy type uses the one-to-one property.
This is new information, right?
Mm-hmm.
Thank you.
And the one-to-one property says, how should I write this? F of A, cross that out. F of X is a one-to-one function. We already defined that. For every X, there's a unique Y, or for every X, there's a Y, and for every Y, there's a only one X, that type of thing. Then F of A is equal to F of B if and only if A is equal to B. If you have a function that is a one-to-one function, then this is absolutely true. Okay. For example, I can give you a nice, easy one-to-one function. Let's say F of X is equal to the square root of X.
I really wish you wouldn't spell F like that.
What?
IFF.
If and only if.
Yeah, I don't like it like that.
We talked about that before.
I know we did.
Okay.
You're right.
If you want to write out if and only if, you go right ahead.
I just put
How
if.
they come up with IFF for that though? It's just an abbreviation. If and only if. So you have two ifs, so IFF. Go figure. So if you have f of x is equal to the square root of x, which is a one-to-one function, it passes the horizontal line test and all that fun stuff, and I tell you that the square root of x is equal to the square root of 9, what can you tell me?
F of X equals 9.
That x equals 9. So you kind of just ignore the square roots and say, well, x equals 9. And that's not even with squaring both sides or any funny, weird thing like that. You're just looking at it going, oh, well, x has to equal 9. If you have something like 2 to the x is equal to 2 to the 5th, 2 to the x is a one-to-one function. So what does x have to equal? 5. Without doing any algebra whatsoever, x is equal to 5. You're not canceling the 2's. You're pretty much just ignoring the 2 bases. All right, so that becomes our first type of solving. If you can get the functions exactly the same on both sides of the equation, you can ignore the bases and work on the other stuff. For instance, if I have 4 raised to the x plus 1 is equal to 8 raised to the 4 minus x, can we solve this equation?
Yes.
How?
You have to put both of those bases in the exponent with 2. You change the base to 2 and raise it to the exponent and multiply the exponent that they already have.
Oh, right. Stop going and doing all 3 steps in one fell swoop. Let's just break it down into small
Okay.
steps. Take 4 and write it as
2 raised to the 2.
2 squared. Take 8 and write it as
2 raised to the 3.
and then whatever's left over kind of hangs out. X plus 1, 4 minus x. Does that make sense so far? So I'm trying to get what's called a common base between these two. What do you do when it's a power to a power? In both of those cases. What do you do with power to a power?
Multiply.
Multiply. That's the one you should memorize. So it's going to be 2 times x plus 1 as the exponent on that side. And then here it's 2 raised to the 3 times 4 minus x. So now that the numbers at the bottom are exactly the same, we could take the powers and set them equal to each other. So it has nothing to do with algebra, it's just the one-to-one property. 2 times x plus 1 is equal to 3 times the quantity 4 minus x. It's just a recognition that those powers have to be the same for those two things to be equal. And then just solve. Oh, cool. I made this up and it actually comes out as a nice answer. Usually it would come up as an ugly fraction. So when x is equal to 2, these two sides have to be equal to each other. And you can check it. If x is equal to 2, this would be 4 raised to the 3rd power. And the question is, does that equal 8 raised to the Well, 4 minus 2 would be 2. So what's 4 to the third equal to?
64.
64, and 8 squared obviously is also 64. So it's a solution. It also works with logarithms. Yay! Logarithms are also a one-to-one function, but there's a small danger with logarithms. Let's say I have log of x squared plus 5 is equal to log Can I change this to minus 5? Change this to minus 5. Yeah, change this to minus 5 instead of plus 1. So x squared minus 5 is equal to log of, I guess it doesn't matter. She just got here. 4x. She left already?
Yeah, don't look. Don't look.
So log of x squared minus 5 is equal to log of 4x. I hope this works. I just made it up in my head. So same thing with the exponential functions. As long as you have log equal to a log, and they're one-to-one functions, you don't have to look at the logs anymore. You only have to look at what's inside. So this turns into x squared minus 5 is equal to 4x because they're one-to-one functions. Now, if there was something else lying around like plus 1 someplace, or another logarithm, you wouldn't be able to do this. All right, how do you solve this equation?
Move the 4x.
Exactly the way it is?
Say quadratic formula.
Well, eventually, yeah, but the way it is.
No.
And I wouldn't use the quadratic formula to save my life until it's the last possible thing.
Minus the
That's why
4x.
you told me not to walk.
I was just wondering.
So, first step should be to move the 4x to the other side to get it looking like a quadratic. But you don't need a quadratic formula. What's the first thing you should try? Factoring. What are factors of 5 to subtract to 4?
Negative 5 and positive 1.
So this becomes x minus 5, x plus 1 is equal to 0. Therefore, x is either equal to 5 or x is equal to negative 1. Remember quadratics? They're a lot of fun.
Oh, God.
They show up all the time, so get used to them. All right, so are both of them my answer? No? Let's try 5. If you take 5 and plug it back in here, you get 25 minus 5, which is 20. Log of 20 on that side. Over here, if you put 5, it would be 4 times 5, which would also be log of 20. So this is a perfectly fine answer. What about negative 1?
What
about
log
next
of
one?
negative number?
Well, if I take negative 1 in here, it becomes negative 1 squared, but negative 1 squared is 1. 1 minus 5 is? So you get log of negative 4. If I plug negative 1 over here, I also get log of negative 4. Seems like it works.
But it doesn't.
Why?
You can't have a negative number. can
You cannot take the log of a negative number. Remember, the graph of logarithm is this, and the domain is from 0 to infinity. It does not include negative numbers. So this is not a solution, because you cannot take the log of a negative number. It only deals with positive numbers. So there's only one solution to that, even though we found 2, only one of them is going to work. Exponentials never have that problem because the numbers that can go into it are positive, negative, or 0, and you don't care. Logarithms you have to be very careful about. You never want to take the log of a negative number. It's not part of their domain. So when you're solving their equations, you have to be a little bit more cautious, plug your answers back in, and make sure they actually work. All right, so that's 1-to-1. Most people don't have a problem with that. Now sometimes there are more than one way of solving these, but other times you're stuck doing it one specific way. Log of x minus 1 minus log of x plus 1 is equal to the constant 2. So what do you think our first step should be? Stare at it. Yeah, that's usually a good step. are the possibilities? Think back to the last thing I was teaching. Laws of
Subtract
logarithms. What does it mean to be logging, subtracting another log?
Division.
It means division. So I can combine these two or contract these two into a single log. So it would be log of what?
X minus 1 over X plus 2.
X minus 1 over
X plus 1.
X plus 1.
What did I say?
The 2. And it's equal to 2.
And you wrote the 2.
Mhm.
I swear. See, you get my brain going the wrong direction.
My
Alright,
brain was going wrong.
so now I have a single log equal to a number. What can I do next?
Hold on. Let me catch up.
Make sure you write 1.
No.
What can I do next? Stare at it.
Multiply both sides by X plus 1.
You can't do that because it's stuck inside of a logarithm.
Um,
Though that would be my first instinct too. You know, if I was just learning this stuff. But once you have that LOG out front, it locks it in. So guess what we have to get rid of?
LOG.
So what's one method of getting rid of LOG?
The inverse.
You could, but that gets messy. What's another way?
I can't remember.
Isn't there a method of changing one into another?
Is it the alien?
No, I don't want to change it to ln. We did this a couple days ago.
Yeah, probably.
Where you take logarithms and write them as
Exponents.
and exponentials and change them to logs. So how do I change this log into an exponential?
Oh, shoot.
Change to exponential.
I can't remember.
Remember I told you that when we were doing these, that it actually can solve lots of the equations that we're going to have. So what's the thing you concentrate on with logarithms and exponent is base. What is the base of this thing?
10.
10. Because it's a common logarithm. There's no number here, so the assumption is it's 10. So you write 10. What's the power?
2.
2. What's it equal to?
X.
X minus 1 over X plus 1.
X minus 1 over X plus 1. Alright. How do you solve for X?
Multiply by X plus 1.
Multiply both sides by X plus 1. What's 10 squared?
100.
100. So that'd be 100 times X plus 1 is equal to X minus 1. Distribute the 100, so you get 100x minus 100 is equal to X minus 1. Then what?
Oh, man.
Hold on now.
I get to talking with you on the board and then I get behind writing.
Gotta get a multi-purpose out of you.
Yeah, no.
So how do I solve this equation?
Subtract X.
Subtract X from both sides, and while you're at it, add 100. So if I subtract X from both sides, this be... I do this right? Oh, that's not minus. This is plus. Alright, so if I subtract X from both sides, that gives me 99X. If I subtract 100 on both sides, it gives me 101. And then divide both sides by 99. So you get X is equal to negative 101 over 99.
Which is what? Oh, I got a calculator.
Oh, no, leave it alone. Just leave it alone. Don't change it to a decimal. But look at it. What's wrong with it?
Negative.
I don't care if it's negative or not. I care if I take a negative number and I plug it back into the original way at the top. It gives me a negative logarithm here. And negative logarithms don't exist. Or the log of a negative number, I should say. And the log of a negative number is impossible, so this thing has no solution whatsoever. So all that work telling us that there's no solution to begin with.
You come up with that problem off the top of your head too?
A long time ago, yeah.
You already knew it didn't work.
Yeah. The most favorite answers of most math students is 1, 0, and no solution. They hate seeing 1, they hate seeing 0, and they hate seeing no solution. They feel like they've done it, well, wrong. Alright, how about this one then? it's a little strange. ln of 6 plus 2 minus ln of x plus e is equal to ln of x. All right, what should I do first? Stare at it. It's always a good first step. Gotta get kind of comfortable with it. Is there anything you want to move around before we start chopping at this?
Would you put all the LNs together and move the 2 to the other side?
I would. So if we put all the ln's together, this would be ln of 6 minus ln of x plus e. When we move him to the other side, this ln of x, he becomes minus ln of x. When we move the 2 to the other side, it becomes negative 2. So nothing wrong with reorganizing an equation. Always a good step. Now what? Back to laws of logarithms. What does it mean to be a log minus a log? Division. What does it mean to be a log minus another log? Another division. So this is going to be ln. What's going to be in the top? 6. What's going to be in the bottom?
X plus E.
X plus e times x. Because he's also a negative logarithm.
So
Rather
could
than
you
log.
not just do x squared plus ex right from the beginning?
You could if you wanted to. Is equal to negative 2. But I was following what I was told, so I kind of just went that way. All right, now what? Whether you distribute the x or not, what would be your next step?
The same thing we did a second ago, change it to an exponential.
What's the base?
10,
It is not.
1.
The base for LOG is 10. The
What's
base for LN is... How about this? I'll give you the name of it. ln is called the natural logarithm, e. The base of ln is e.
Oh, okay.
So this goes e to the negative 2, remember, the power's on the other side, is equal to, and I'll write it properly, 6 over x squared plus ex. Now what?
Multiply both sides. X squared plus EX.
Multiply by the common denominator, which is x squared, plus ex. So you get e to the negative 2 times x squared plus ex is equal to
6.
6. I'm curious, what the heck does e to the negative 2 mean?
I don't know, what does it mean?
I don't know, I'm asking you.
You know what it means.
I do know what it means, I'm asking you. What's e to the negative 2 mean? Yes, you should know this.
Would it be a fraction?
It's definitely a fraction.
Is this supposed to be in our notes?
If it's 2 to the negative 2, yes, that's 1/4. This is e to the negative 2, so that would be... if I have a to the negative 2, what's that equal to?
1 over A squared.
1 over a squared. So if I have e to the negative 2, that's equal to
1 over e squared.
1 over e squared. So this can also be written as 1 over e squared times x squared plus ex
I mean,
is equal to
does
6.
that look easier to you?
Well, there's a reason. Up here, when we were at 6 over x squared plus ex, what did we do to start solving the equation? You multiply by the common denominator. Well, guess what? We have another denominator. So what should we multiply by? E squared. So if you multiply both sides by e squared, we're adding this piece in here. Over there, the e squares cancel. Over here, you get 6e squared. So this becomes x squared plus ex
Equals 6e squared.
Yeah, I could write that. I'll write it. Equals 6e squared. What does this look like? In a weird way. What does it look like? Looks like a quadratic again. It has 3 terms, and there's an x squared involved. All right. So let's see if I can change it to the quadratic form. So you get x squared plus ex minus 6e squared, and this will equal 0. Anytime you're running into a quadratic, you always want to start getting it equal to 0. Can you factor this? If I ignored the e's, could you have factored this?
Mm-hmm.
You would say factors to 6 is subtracted to 1. What are factors to 6 is subtracted from 1?
3 and 2.
3 and 2, right? So you go and go x plus 3x, minus 2, right? But if I multiply those two together, it doesn't give me the e's. So where do the e's go in this little factoring? Just think, if you FOIL, you go 3 times negative 2, that gives you negative 6, but I want e squared.
The 3 and the 2.
What about them?
You put the e's next to them.
Yep. It would be 3e, 2e. And if you FOIL this out, you'll see that you get negative 2ex, positive 3ex. When you add those together, you just get ex. When you multiply the last, you get negative 3, or positive 3e times negative 2e, which is a negative 6, e squared. So my answer is going to be x is equal to negative 3e, or x is equal to 2e. Are both of them my answers? Neither of them my answers? Or only one of them my answer?
I don't know.
You tell me. Remember, it has to go back to the original equation and actually work. So if I take 2e, more than likely it's going to work. What about negative 3e?
No.
If I plug negative 3e right into this last piece, this ln of x, it would be ln of negative 3e. What's wrong with that?
Negative.
You can't take the logarithm of a negative number. E is like 2.718, something like that. So this would still be a negative number. So the only answer here is 2e. Logarithms. Oh, I already did that. Alright, let's see what other kind of nasty equations they can throw at you. Oh, yeah, I forgot that one. We basically did it the other day. I'll reiterate it. Oops. We'll do that in a second. Say we have 5 raised to the x minus 3 is equal to 17. This is what's called a common exponential equation. Usually you don't get the base thing. Now, if it was possible to change a 17 into a 5, 5 raised to some number, it would be wonderful because then the answer would just spit out. But I don't see a nice way of doing that. So what's another method I could try?
Taking the log or ln.
Do the log or ln of both sides. Because what we're trying to solve for is up high, and logarithms are famous for bringing that out front. So either log or ln, which one do you want to do? Darn, I was hoping you'd say ln. But we'll do log. So log of the left-hand side, log of the right-hand side. So inside would be log of 5 raised to the x minus 3, and the other side would just be logarithm of 17. Right. Now what?
The x minus 3.
The power drops in front, so you get x minus 3 times log of 5 is equal to log of 17. Now, depending on your style of solving a linear equation, what would you do next? That's one way of doing it. What's the other way of doing it?
You can move the 5 to the other side, the log of 5 to the other side.
That's what
So
you
just
divide it
as
across.
log of
17 over log of 5. But that's what she was just saying. What's the other thing you could do? Just want to make sure I cover both bases. So you could divide it across, but the other option is to take log of 5 and distribute it into x minus 3. So it would be log of 5 times x minus 3 log of 5. You give it to both of the terms on the inside. Of course, that makes your expression get rather long. So it's safer just to divide both sides by log of 5. So now you have x minus 3 by itself is equal to log of 17 divided by log of 5. Now what?
Plus,
Add 3 to both sides and you've solved your equation. What's it equal to approximately? Requires calculator. And someone said they brought their calculator.
Yeah.
Yeah, you're so excited about that.
well,
Friday classes.
Yeah, they're horrible.
I wouldn't say horrible.
Yeah, 4.76.
Mhm.
4.76? So it's approximately 4.76. Not that bad, right? Now what's cool is you could do it like the last example. You will get to the answer. But then your answer is going to be really messy. But it'll be right. It'll be right. It might look a little different than what we're going to do. But it's usually easier to try to get the bases exactly the same. So is there any way of writing 1 over 125 as a 5 raised to some power?
yes.
What is it?
5 raised to the negative 3.
5 raised to the negative 3. Because you can write it this way, which means you can always write it this way. 5 cubed is 125. 5 times 5 times 5. So what can I do here? Well, I could ignore the 5's completely and get 2 minus x is equal to
Negative 3.
negative 3. What's x equal? 5. X equals 5. And you're done. But you could have logged both sides and went that whole route and typed it in your calculator, and the answer would spit out as 5. It would just take longer. All right. Is there any other style? I always want to make sure I hit all of the ones that they talk about. Kind of did that. Let's try that one. This is 44 out of the book. E to the 2x minus 2e to the x minus 3 is equal to 0. Doesn't that look pretty? What does it look like, though?
It looks like a quadratic,
It looks like a quadratic.
but you gotta substitute.
You can, or if you're really good, you can just look at it and factor. But I highly suggest you substitute. I usually use u. So if you do this substitution style, you let u equal the middle variable term. Well, the middle variable term is e to the x. Don't bring the 2 with it. That is just a coefficient. So if I let u equal e to the x, there's a name for this. What is it? Oh, quadratic form. Quadratic form. So if I let u equal e to the x, the next thing I need to replace is I need a u squared. So if I square e to the x, what's e to the x squared?
E
Yeah.
to 2x.
E to the 2x. Because power to a power, you multiply. All right, so in this expression, if you see e to the 2x, you could replace it with u squared. If you see e to the x, you could replace it with u. So this becomes u squared minus 2u minus 3 is equal to 0. It's a neat technique, but once you start seeing the pattern, you don't have to switch things to u's. All right, here, factors of 3 that subtract up to 2.
Negative 3, positive 1.
So u minus 3, u plus 1. And setting both of those factors equal to 0, you get u is equal to 3, and u is equal to negative 1. Okay, great, wonderful, except for one problem. When we started the equation, we were solving for, no, x. Always solving for x. The only unknown there is x. E is a number. 2.718, blah, blah, blah. But I solve for u here. I want to get back to x. So what does u equal in terms of x? E to the x. So you have to go back to your original substitution. So this becomes e to the x is equal to 3, and e to the x is equal to negative 1. Okay. How do you solve those two?
Do you take the alien on both sides?
You could, or, better yet, a lot less work, rewrite the exponential as a logarithm. What's the logarithm base you want to use? Well, e. What's log of base e? Log base e? I'll write it. Log base e of 3 is equal to x. Have you ever seen me write this?
Mm-mm.
What's log base e? What is e called? The natural number. So log base e is also known as the natural logarithm, and natural logarithm is represented by ln. So this is saying that x is equal to ln of 3. All right, do it to the other one. This becomes ln of negative 1 is equal to x, the base of the natural logarithm, raised to the other side is equal to x. What's wrong with this?
You can't have a log of a negative number.
So this one is no solution there. Can't have the log of a negative number. So the only answer here is x equals ln of 3.